Okay, today's video, we're going to talk about triangles, but not about the types of triangles or finding missing angles in triangles. We're going to talk about how to prove triangles are congruent. So congruency is usually you have to prove all the angles in the figure are congruent in one figure to another, and all the sides are congruent in one figure to another. So if you had a triangle, that would be 6 parts. But there are some special ways we can prove shortcuts, we kind of call them, prove that two triangles are congruent. So let me go ahead and first give you let's title this triangle congruency. And let me give you the list of the ones that do prove triangles are congruent. There are 4, and then one kind of exception. So one of them is side, side, side. If you can show that 3 sides of one triangle are congruent to 3 sides of another, then you can say, yes, they're congruent. Number 2 is side angle side. So if you can show 2 sides of one triangle and the included angle, it's important that you pick it's the included angle that is shown. You can say they're congruent. The other one is angle side angle. Number 4 is angle side. And these are what we call the main 4 that work. Now, there are 2 that don't work. If you have 3 angles in one triangle, so these are the ones that prove congruency. And these are the ones that don't prove congruency. So if you have 3 angles in one triangle and 3 angles in another triangle that are equal, you can't necessarily say they're the same size triangle. And example I could draw real quick is if I had a triangle that had a 40 and a 70, let's just make an isosceles triangle, a 40, a 70, a 70. I could come over here and draw another bigger isosceles triangle and make the angles 70, 70, and 40. And it's bigger, but the angles are the same. So when you make these triangles bigger, the angles don't get bigger. So just knowing that the angles are the same can't tell me what size it is. So that one doesn't work. There is another one that doesn't work, which is SSA or ASS, the bad word. I call this one the bad word. So it doesn't work either, except and the difference of this one and this one is that in this one the angle is marked in between, and this one the angle is not. I'll show you some examples of this in just a minute. Now there is an exception to the side angle, and it's when you have a right triangle. And we call that the hypotenuse leg theorem. Because it only works in a right triangle, it gets its own name, and it's called the hypotenuse leg theorem. Okay, let's look at a couple of examples of this. So this is a classic one that they do what I call now. Let me just tell you, if I didn't say this already, that in order to prove these triangles are congruent, because all these theorems are going to require that you have 3 marks in one triangle and the corresponding 3 marks in the other triangle. And if you have less than 3, you can sometimes add markings depending on the situation. And you can't just add them because you feel like it now. It would have to be because maybe you had parallel lines, and you could add some alternate interior angles. It could be because you had shared sides. We can add that by the reflexive property. In this example, let's just make these parallel lines. So if you think about these being parallel lines, And let's go ahead and mark that this side is congruent to this side. We'll put some letters on this. So the question is going to ask you, is this triangle FEG congruent to this triangle HIG? And if you look at the triangles, this triangle has one mark and this triangle has one mark. So a lot of students are tempted to say, no, we don't know because you said we had to have 3 marks. But we know we can mark these vertical angles, those angles that sit across from each other. When you have those 2 intersecting lines, those are always equal to each other. And then if you think about this picture, if you think about these being the transversal, there is a video out there on lines and transversals you might want to go look at. And this would be the transversal, and these would be the 2 parallel lines. We could do either set, but this angle right here would be what we consider alternate interior. We're going to mark it with 2 marks to differentiate it from the 1 mark. So those 2 angles were equal. Well, now I do have my 3 marks. Let's go make sure it's one of the 4 that we talked about up here. So I have 2 angles marked, and I have one side in between. I have the same thing over here, 2 angles marked and the side in between. So this would be a yes. And if they ask you to explain, it's just going up here and picking the right theorem, angle, side angle. All right, let's look at another one. Oh, no, let me do one thing real quick. So I'm going to get this patty paper because I want to show you sometimes what they're going to do is they're going to want to, let's see if I can find a pencil because this doesn't work well unless you have a pencil. Let me get a pencil. So sometimes they're going to, if you can prove these 2 triangles are congruent, remember we talked about that triangles have 6 parts and we've only got 3 parts of the 6 right here. But now that we've proven they're congruent, we know the other 3 parts are also going, and that's what they're going to ask you sometime. You'll see these problems in a proof every now and then, and that's what they'll be asking you to prove a certain angle. So the best thing to do is to get some of this patty paper, and they will have this when you're testing, and you can draw out the first triangle. Now you need to, because a lot of people think this has been just flipped over, but if you notice, if I flip it over, here's the 1 mark, and the 1 mark is up here. So this thing has actually been rotated around. And then you can see that the marks match up. So let's say the question had said, angle, or not, angle F is congruent to what angle? Then you could see that F is right here, but when we rotate it and match up the marks, F falls down here on this bottom angle, which is our H. So angle F would go with angle H. And again, that's what they're asking you to do sometimes in these problems. Okay, let's look at another one. All righty, so is ABC congruent to DEF? Well, if you look at these triangles, they both have 3 markings. Now, that doesn't always mean that they're automatically congruent because it could be the 2 that don't prove, but they are all sides, so we know that. I go back to my list. Side, side, side was one of the one that does prove congruency. So this would be a yes. And it would be by side, side, side for your explanation. Now let's get some patty paper and let's talk about if I said angle A is congruent to what angle. You do have to be careful here because it's not just because this angle is at the bottom left, it doesn't mean that it's congruent to this angle right here. We have to see if this triangle has been rotated or flipped. So we're going to trace it out just like we did before. Make sure you put the letters on there so you'll be able to match up what letter goes with what. And we're looking what A goes with. So see if I just slide it over, the 1 marking is not, it's on the 3 marking. So that's not, That's not what works. So we need to see if it's been rotated or flipped. It looks like it's just been rotated. So that's how it would match back up. We're looking to see what A matched up with. So A's up here at the top. So A would go with E. So A matches with angle E. Okay, let's look at another one. Okay, so if I ask you if these two triangles were equal, EFG and HIJ, so the first thing I notice is there's only two markings in this triangle, two markings in this triangle. And you might go, well, can I add anything like shared angle? Vertical angles, alternate interior angles, and shared sides, and they don't have any of that. So in this one, you just have to say not enough information. And that does happen sometimes, that they don't give you enough marks and you can't add your own. But I just still want to stress to you that you saw the other example where I was able to add some marks. So be careful that you will watching out for where you can mathematically add marks now, not just because you feel like it, but where you can mathematically add marks. Okay, let's look at this one. All right. And let's see, what do I want to mark here? I'm going to mark this angle and this angle. Okay, so again, looking at these two triangles, I only have 2 marks in one, 2 marks in the other. But anytime they share a side, that also gets marked. And that's marked in both triangles. You can draw them separately if it helps you see that. But the top triangle has 2 angles and a side marked in between, and the bottom triangle has 2 angles and a side marked in between. So this would be a yes, and it would be by 2 angles with the side in the middle. So by angle, side angle. And I hope you can see that this thing has just been reflected down. Go ahead and draw it with the patty paper though. And again, the reason that's important is because they could say, again, I think it's pretty evident in this picture, but if it's not evident, they could say side GF goes with what, or is congruent to what. And what you could do is you could draw your figure. And then, like I said, this one has just been flipped down on the other one. So do you see how GF right here falls on top of this bottom line HF? And like I said, I think it's pretty evident from this picture, but the patty paper will help you with that. Okay, let's look at this picture. Got a couple more, and then I think it'll be good on this topic. Okay. And let's see, let's call this EGHI. So scoot this up, you can see it. So is EIG congruent to HIG? And again, a lot of students will be tempted to say no, because this triangle only has 2 markings and this one over here only has 1 marking. So they think there's no way you're going to get that many more marks out of here. But if you notice, this right angle also means that this is a right angle because we have a straight line, so it makes 180, and GI is shared in both triangles. Now be careful, this is not hypotenuse leg because we don't know anything about these hypotenuses, but this would be a yes by side, angle, side. You see the markings? It's 2 sides with 1 angle in between. All right, let me do one last one that would be HL, just so you can see it. We'll do the same picture, but I'll Same kind of picture, but I'll mark it with HL. So if I mark the hypotenuse instead, same kind of picture. I do see that I can call this a right angle, and they share a side. No, oh, sorry, let me scoot that up. Now look at the difference between these two. This has two sides, but not the angle in between, because that would be that one. It has two sides and the angle not between, which is side, side, side. If you notice, this would be side, 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 the one that we said on the other page that doesn't prove congruency, but because it's a right triangle, that is the exception. So this is the exception to side, side angle, which is hypotenuse leg. So it would be a yes. These two triangles are congruent. Okay, folks, that'll do it for this video. Hope to see you on some of the other videos.